Thank you for joining me. Welcome to TJ's Maths Clinic. Still on WAEC 2025. This is for school candidates. With us here is Further Mathematics, Paper 2 May June, Section A, Question 8, the last part of Question 8. This Question 8 carries 6 marks. In my previous video, I have solved Question 1 to 7. Let's consider this Question 8. A force of F Newton acts on a body of mass 50 kg and changes its velocity from 30 meter per second to 40 meter per second in 6 seconds. We are asked to find A, the magnitude of the force, B, the acceleration of the body, C, the distance covered in 9 seconds when the initial velocity is 30 meter per second. We are asked to take G, that's acceleration due to the gravity, as 10 meter per second squared. Let's consider this question. This is from dynamics, that's the first thing to do, which is one of the branches of mechanics. Let's look at how we can handle this. Let's write down the solution. Solution to A now. We are asked to find the magnitude of the force. Let's bring out the information from the question. The force F is not given. Mass M is 50 kg. Very important. Then it changes its velocity from 30, as initial velocity is 30 meter per second from the question. Then final velocity, which is V, is 40 meter per second in 6 seconds. Time T is 6 seconds. We are asked to find the magnitude of the force. You know, force is mass times acceleration. Okay, we can either find the acceleration because acceleration is change in velocity with respect to time, or we can use force F, which is equals to mass into change in velocity divided by time t. We can use this formula direct. You can see clearly that this change here is what is our acceleration. So the force F now will be equals to, we can substitute M is 50 into V is 40 minus 30 divided by T, which is 6. The force F now will be 40 minus 30, that's 10 times 50, that will be 500 divided by 6. What will be the force? 500 divided by 6, we have 83.3 Newton to 1 decimal. So this will be the magnitude of the force. So this will be the solution to A. Okay, let's move to B. B said acceleration of the body. Acceleration of the body. What will be the acceleration of the body? Very simple. Let's remove this. Permit me to clean A so that we can move to B. Solution to B now. We are asked to find acceleration A is not given. We have our mass M as 50 kg. Then we have V now as 40 meter per second. Then U, which is the initial velocity, 30 meter per second. And acceleration, then time t is 6 seconds. Acceleration A is nothing but change in velocity with respect to time t. Change in velocity means final velocity minus the initial velocity. This will be 40, take away 30 divided by 6. What are we going to have? 40 minus 30 is 10, that will be 10 divided by 6. Acceleration A now will be 10 divided by 6. What do we have? We have 1.6667. Approximately, we'll have 1.7 meter per second squared. So this will say to be the acceleration, 1.7 meter per second squared. So that is the solution to B. It's very easy. The last part, we are asked to find the distance covered in 9 seconds. Let's look at the solution to B. Permit me, or let me clean this part so that we can look at the solution to C. Solution to C now. The distance covered in 9 seconds, time t is 9 seconds, when the initial velocity u, which is the initial velocity, is 30 meter per second. Acceleration due to the gravity is 10 meter per second squared. Uh, then acceleration, we know our acceleration A as 1.666. Let me leave it to 4 decimal. Very important because of premature approximation. Using equation of motion, we are asked to find the distance. The distance s now is u initial velocity multiplied by t plus half at squared. Or we can use g. We can either use g here or we use a. Let's use g. Since we have g, we can use gt or a. It's still the same thing. Since we know our time t as 9, then we know our initial velocity as uh, 30 meter per second. But we are take to take g as 10. So let's use this. Very important to find the distance now. So let's find the distance. The distance s now will be u, which is 30 multiplied by time t, which is 9 plus half, multiplied by acceleration due to the gravity, which is 10 times t squared. The time now, which is 9, that will be 9 squared. Very important. We can use this calculated acceleration. Because this is the calculated acceleration, we have to use acceleration due to the gravity, which is g now. So the distance s now will be 30 times 9, that's 270, plus 9 square is 81 times 10, that's 81 times 10, that's 810 divided by 2, that will be 405. So we can add the distance now will be 405 divided plus 270, that will be 675 meter. Distance is measured in meter. So this will be said to be the solution to C. As I said, we can't use this acceleration because this is the calculated acceleration. So we use acceleration due to the gravity g, which is 10 meter per second. The question even said we have to take g as 10 meter per second. So the distance is nothing but 675 meter because distance is measured in meter. So this is the solution to this question 8. Thank you for watching. See you in my next video. You can follow me on TikTok, Instagram, and Facebook. God's willing, in my next video, we'll look at the optional parts, which is question 9, 10, 11, 12, 13, and 14 to 15. God's willing. Thank you for watching. See you in my next video.